Capacitors store charge within a potential difference. They stop charges from flowing within a circuit so that they can flow again later. As we discussed in the previous podcast, charges build up within a capacitor up to a certain level. After this level, a current will flow because the potential difference made within the capacitor is big enough to overcome the resistance of the dielectric. Up to this point, the charge going into a capacitor can be made to come out of the capacitor again. Once the external potential difference has been removed, the power turned off to the circuit, the capacitor will discharge. The negative charge on one plate and a positive charge on the other plate will repel each other and cause a current to be generated in the opposite direction to the one initially applied to the capacitor. Both of these processes require energy. The initial charging of the capacitor converts electrical energy in the form of energy equals current times time times voltage, or W equals ITV, into the form of potential energy, electrical potential energy, in the form E equals QV, where Q is charge and V is potential difference. The trouble is that the potential difference in a capacitor is directly proportional to the charge stored in the capacitor. As charge increases, potential difference increases at the same rate. If you plot charge against potential difference for a capacitor, you would have a linear graph with a constant gradient going through zero. If energy is charge multiplied by potential difference, then the energy stored by a capacitor is the area under this charge potential difference graph. The area under the graph is the area of a triangle, which is half base times height, or half charge times potential difference. Using our definitions of capacitance, C equals QV, from the previous podcast, we can derive two further equations for energy in a capacitor. If we rearrange C equals QV to become Q equals CV, charge equals capacitance times by potential difference, then energy equals half QV becomes energy equals half CV squared. Rearranging so that C equals QV becomes V equals Q over C, then energy becomes equal to half Q squared divided by C.